Welcome to this ARDC Australian BioCommons webinar. Through these sessions, we hope to share useful information about the latest digital techniques, data and tools. My name is Christina Hall and I'm the Australian BioCommons Training and Communications Manager, and we have Susanna Bacon from ARDC behind the scenes making today's session work. Before we start today, I'd like to acknowledge the traditional owners of the lands on which we work and pay our respects to the elders past, present and emerging. We really appreciate those of you joining us live today. You'll have the opportunity to ask our speaker questions via the Q&A function, and these will be addressed at the end of the presentation. This session will also be recorded, and if you'd like to revisit it in the future, you'll find it on the Australian BioCommons YouTube channel, along with previous recordings of other webinars and workshops. We hope you'll keep in touch with us to hear about future webinars on the channels listed on the screen here. Today, we're lucky to have with us Dr. Allison Heath from the Centre for Data-Driven Discovery of Biomedicine at Children's Hospital of Philadelphia. Allison is the Director of Data Technology and Innovation at D3B, where she provides technical and collaborative leadership to platforms for data-driven discovery. She supervises data products and platforms team who work in data-intensive computing, bioinformatics and cloud computing, including leading the development of the Kids First Data Resource Centre. Prior to joining CHOP, Allison was the Director of Research at the Centre for Data-Intensive Science at the University of Chicago. In that position, she led a large-scale data-intensive project or two, including the NCI Genomic Data Commons, the Open Science Data Cloud, and the BioNimbus Protected Data Cloud. Allison came to solving big data challenges with a PhD in computer science from Rice University in Houston, Texas, and she's committed to accelerating discovery and translational research by democratizing data access and analysis. Today, Allison will tell us about Cavatica, the cloud-based platform for collaboratively accessing, sharing, and analyzing cancer data.
Great, thank you so much, Christina. It's really great to be here today and to participate in this webinar. This is part of a collaboration between our teams here as well as a number of partners in Australia, really trying to accelerate the different discovery and especially in the arena of pediatric cancer. So today I'm going to talk about one of our platforms that we've built out. This is called Cavatica. The name actually comes from Charlotte's Web. So if anybody has read the E.B. White book, a motley crew of characters come together to save an innocent life. And Charlotte the spider, her last name is Cavatica. And so that's really where the name comes from, and the idea of really connecting different data sources, different resources, originally, on behalf of pediatric cancer, but the platform's really grown and we have a lot of disease types in structural birth defects, rare diseases, and indeed bridging kind of across the pediatric and adult landscape. So I'm going to talk today a little bit more about some of the technical aspects of Cavatica, introduce some capabilities of the different platforms, and then show a little bit of a demo of how we also think about not these platforms being siloed, but how they integrate with other data resources that are coming along, online around the world. So I'm going to start with the kind of basic unit of a Cavatica project. So I like to say Cavatica is open to anybody around the world. You can create an account there. We also have special functionality with the National Institutes of Health in the US to be able to log in and see controlled access that's controlled and governed there that I'll talk a little bit about. But when you first get into the platform, the thought is to really have collaborative projects and different ways of organizing your data so that you can have multiple different tiers of how you share and provide it. So by kind of default in the platform, we have kind of projects are what most people work on. By default, they're private. So only you can see the data in there. You can think of it as your own local environment. It just happens to be in the cloud. You have full control, governance around it. You can add collaborators to those projects, and you can share and create multiple different projects, and I'll show a little demonstration of how that works. As part of the Cavatica project, when this first launched in 2016, this was a new platform, and so we really started incorporating different data sets. So if you create a data set, you could also publish that on the Cavatica platform. I think today, we're seeing data sets come from multiple different places. So Cavatica is one place to do it, but we've really integrated with data sets from other places. The third one is controlled projects. So the idea of being able to publish your project online, be able to view what it's about, the abstract, but not actually see the data underlying it. So, the idea being that if there are projects that are going on that you're interested in joining or interested in collaborating with, being able to make that visible out to the research community. So within a project, there's multiple different organizational parts underneath it. And I'll walk through some of this, but within a project, as again, I said, you had members. So you have someone who owns the project, you can add collaborators. You have files, and these are files that are living in the cloud. And we'll talk about different ways that you can bring your own data to the platform or reuse data that's already there. And then one of the most kind of powerful things about Cavatica is really its workflow system. So being able to bring your own tools, reuse other people's tools, have different apps and tasks that are packaged up to be deployed in a scalable fashion across the cloud. Similarly, under the files, you can request access to data that's already in there. You could upload your own. With apps, you can reuse existing apps that other people have published on the platform, or you could create your own using various kinds of underlying technology. So as I said, anyone can come and create an account. And there's two ways. One is that you can create your own account, or if you happen to have something called an BioCommons, which is the researcher identifier for the NIH in the US, you can also use that, and that would also be able to be reused to grant access to controlled access data in, for example, dbGaP or SRA. So this is a view of a project on Cavatica. As you can see, this is Young-Kun Zhu, my colleague here, who's our director of our bioinformatics engineering at our center, who's also here as a panelist today. And the first view you see is on the left, your projects. So these are different projects that have been created. You can see that he's created some, other people have created them, and he's joined them. And then on the right are the different tasks that have been run on the platform. So you can see that, for example, doing a fair bit of RNA-seq fusion work here. Once you click into a project, you have your dashboard. So you have kind of a description on the left. We actually encourage people to modify this as you start working the platform. As you might imagine, you have different projects, so you can add a description. And then if at some point you want to make it a controlled project and have it advertised to the world, that would be part of the information that other people could see. But at this point in time, what you're looking at here is private to yourself and only shared with the members that are on the right-hand side there. And you can see that there's multiple different levels of access that you can grant people. They can have write access, copy, execute, admin, and then the different tasks that are being run within that project. So this is kind of a full-out view of that. And then in the upper left, you'll see that you have the dashboard here and then different functionality for files, apps, and tasks that we'll go through. So as I said, you can already add files that are existing on the platform that you have access to into your project. So one level of this, for example, is public files. So a lot of the references, a lot of other public data sets, 1,000 genomes, things like that are available on the platform that you can immediately pull in to your environment and reuse. No need to upload or do any kind of data transfer there. And then, as I mentioned before, there's data sets. So these are data sets that have been published on the platform. You can see a list of them. This is a little bit of an older view. We've actually cleaned this up a fair bit. And you can go in there, select the different data sets. And again, there's a description of what those are, who controls it, and then you can submit a data access request. So for example, here we're highlighting at CHOP, we're the Operations Center for the Children's Brain Tumor Tissue Consortium, which is a large-scale consortium-funded data set that you can request access to that we make available in real time on the Cavatica platform. So as I mentioned, there's several different ways to access your data. So you can use your data on Cavatica directly. You can use different ways to download it or bring it down. But really the power of this that I'll show you is that really when I try and do kind of the large scale workflows on the cloud itself, so inside of the Cavatica platform. And then once you get to the high level results, that tends to be where we see people wanting to download them. However, there is multiple different ways that if you do want to download it there, and something New that's been added and more of a kind of beta feature, but is interesting, is the 7 Bridges file system. So this allows you to mount your projects locally. I wouldn't recommend using this for large-scale workflows, but it's nice for example, IGV or other visualizations that you have a local app there that understands how to look at some of these large-scale files. You can mount it there and work locally with the data that's in the Cavatica system. So that's kind of the overview of the projects and the different ways that you can look at data, manage the different data types. As I was mentioning, one of the real powers of using these cloud platforms is really being able to have the ability to scale workflow and tools. So as many of us know, oftentimes bioinformatics tends to be very batchy. So you get a huge, large new data set. You want to run, a couple hundred, couple thousand kind of workflows, and this is really where some of the features of the platform shine. But you have to get to that point where how do you bring your workflow, how do you bring your tools to the cloud? And so there's multiple different ways to do this, and really we've emphasized with Cavatica, how do we make sure we use standards to do this? The point of this platform is to be able to bring in tools, export your tools, use global standards, and then the platform can optimize that for a specific cloud environment, in this case, Amazon Web Services, in the near future, Google Compute as well. But it means that you can develop and create your workflows in a standardized fashion that can be shareable among different platforms, among different collaborators, is the idea. So two of the key enabling technologies underpinning this, that it's not just in Cavatica, but we're seeing many other systems use. Docker is one of them to really package up the different tools to make them portable. This is a general technology for anyone who hasn't used it before or used it in web services, other ways. But for bioinformatics, it's really great because you don't have to worry about dependencies between different tools, underlying packages. You can just install, the version that you like of SAM tools or BWA, something like that, in a Docker container and be able to move that around. However, in Docker, it's just that one app, and so you need a way to define around your container what are the inputs, the outputs, how do you want your different workflow to actually run? So the different steps in your bioinformatics workflow, how do you put that together? And with Cavatica, it uses common workflow language, which is one of, I think, a handful of standards that folks are starting to standardize today. And what's nice about that is because it's programmatic, it's in code. Even if you do want to move to a different workflow definition language, it's something that you can point to. It's not just a natural text description. So common workflow language is both the wrapper around the tools that are packaged up in Docker, as well as the way that you define the workflow of your inputs and outputs. How does the different data move through your bioinformatics workflow? And again, I think one of the things about these emerging platforms that is really nice is being able to share and reuse other people's pipelines and workflows. So often if you're working with a different group and they've already come up with a workflow that they've benchmarked and they like, you should be able to take your data, run it through their workflow and do a cross comparison or cross analysis, and not have to redo that work or try to start from scratch to build your own pipelines. And so this is really part of what the platform tries to encourage. So there's a lot of public apps developed on there, and then you can bring your own app and publish it there, as well as some of the consortium work that we've been doing and some of these larger scale projects like the Kids First Data Resource Center. We're starting to publish our applications and workflows there for other people to reuse. So as I said, right now there's about 300. I think it's getting close to 400 different workflows and tools. And then there's a workflow editor. So if you are starting to think about what kind of workflow do you want to do, what kind of tools might you want to use, I would say that the workflow editor is a really great place to start. And you can do kind of visual development, as you're seeing here in this animation, where you can search through public tools, look for the SAM tools index, drag and drop it into the workflow editor, and then connect the inputs and outputs due to those definitions in CWL to really define your pipeline and refine it. So that's one example. I think this is a nice way to get introduced to it. But the fundamental building block is, you want to bring your own tools. So you have the latest and greatest structural variation analysis, a fusion caller. You're developing a method or tool yourself. How do you bring it onto the platform? So the first step is to, go into the create new app interface, and there you'd be able to create a new tool for the platform. So I'll just walk you through some of the key steps here. So you can see that when you bring your own tool, the very first thing you need to do is have a Docker image. So that's the first thing, that it needs to be Dockerized. You can use in Cavatica, there is a built-in Docker repository, or you could integrate with an external one like Docker Hub, etc. And then you have different information that you need to provide about your tool. So you have the tool Docker image, the tool basics, so what's the basic command line, input, output, arguments, parameters, and then the final command line preview there. So as an example, if you're wanting to bring SAM tools, which is actually already there, but perhaps you want a different version, or you want the latest version, you could bring it there. You'd have your base command. This would be SAM tools index. You have a whole bunch of parameters that you can adjust of, what kind of different threads, what kind of different parameters do you want, and then some of the key important ones for being able to put this into a workflow, or what are the input and output piles there, as well as starting to define some of the computational resources that you might need to run this tool. And then this is the visual editor under the hood. As I was saying, this is actually CWL, and you can see that there on the right. So if you are a user who would much rather do the kind of coding or the, in that level of work, it's all behind the hood. You can choose to decide, visual editor, nice and quick, go through it, really want to fine tune it, or, you have reusing someone else's template, you can use and always go under the hood to the underlying code of CWL. So again, kind of the workflow editor component. The other thing that I didn't talk as much about, but it's really nice, is every time you modify a workflow, there's version control. So as you update, change your workflows, you can look at the previous versions, create new versions, and always understand and have provenance of exactly what set of tools that I use to run as part of my workflow. So one of the things also about building some of these platforms are, when I'm presenting this and when I'm looking at it, you kind of get the visual interface, the demos. I think really as you're trying to scale, or you're trying to, work between different platforms, what's really nice are some of the APIs that are available. So pretty much every functionality that we demonstrate or show on the front end has a corresponding API endpoint. So you could upload your workflows as an API, as well as there's provided R clients or Python clients if you want to use the platform more programmatically. So what we tend to see, I think, as a mode of working with these platforms is you really start from the user interface. If you just need to run a handful, or you have a kind of interactive analysis you want to do, you can do that. If you really want to scale, you can use the APIs and really create different kind of automations or other things with your bioinformatics workflows. I mean, just really depending on the use case. So it's a very flexible platform for those different mechanisms. And then as I said before, I think the other thing is everything about your workflow on the platform is tracked. So the idea being that anything that was done should be reproducible, assuming that the source data is available, but you should be able to track and see all the information about the exact workflow that was run, version control, information about how long it was run, the cost in AWS, and then the different traceable reports, logs, output that's being used. So anytime you run a task, that task information is on the platform for future reference, unless for some reason you ask to delete it, but everything on there will have the stats, the logs, detailed information about it, metrics on the different resources that were used, and then being able to go and see all that information, both in once again in the UI view as well as on a backend API view. So that's really the features of the platform geared towards running large-scale bioinformatics workflows like alignment, variant calling, different kinds of things that you might want to do on multiple different samples. At the same time, one of the powers of the cloud is that the data is right there. How do I do an interactive analysis? Even at the variant or VCF or high-level data, I want to do something really quick. I don't want to have to download all those files and manage them locally, or make sure that I'm always in sync with the latest data set that's there. So increasingly working together with Seven Bridges, again, thinking about how do we do interactive analyses, how do we support that level of bioinformatics work that we really want to do, and we also want to do collaboratively. So how do you have a workbook or a workspace where as a bioinformatician, you can go in there, create kind of the different plots and graphs, and then maybe work with a clinician or a basic biologist looking at some of the interesting pathways and being able to share those results and get feedback kind of in more real time versus going back and forth is some of the things that we're thinking about and always really interested in hearing about how to make this better. So I'll go through some of the interactive analysis features as well. So this is just an outline of what I was talking about. So one of the features is called Data Cruncher. So really the idea is to be able to do fast prototyping, implement different kind of tertiary analysis tools. So after I get through my primary workflow, I want to do plots, I want to filter things out. I know a couple of samples are bad. I want to look at the different heat maps. We can do that within the same project that you just ran your workflows in. So you can run your large-scale workflows, you can have your output files, and then right in that same project with the same collaborators, you can start up a Jupyter notebook, for example. So again, here's the project view, and then in the upper right, you'll see interactive analysis. There's also Genome Browser, and then some beta features that we've been testing of looking at variants as well. But really for today, I'm going to focus mainly on the Data Cruncher feature. So right now, you can do both Jupyter notebooks as well as more recently, our studio is in beta. So always happy to get feedback on it, but I think the Jupyter notebooks right now is the real solid analysis setup right now. So I'm just gonna go back because I did want to show, I don't think it shows in here that you can start it, and then you can also say what kind of compute requirements do you want. So by default, it's pretty small, but if you want to do a really large in-memory computation or something like that, you can choose the different resource levels that you are going to be used for that notebook. The other thing that we also are seeing more heavy usage of is this actually a terminal feature as well. So in terms of Jupyter Notebook, you can have Python, Julia, and R as the different kernels that you use. But there's also a terminal feature here, which is similar to having a VM that you can install tools into. You can see kind of on the right here. And so this terminal has access to all of the data files that were in your Cavatica project. So both the workflows, the Jupyter notebooks, as well as these terminal features, you can have direct access to all the data that's in your project. Okay, so I got through that a little quicker than I expected, but that gives us a little more time to go through some of the demo, as well as, I'll be happy to take questions. But as I was saying, those are kind of the high-level features of Cavatica as a platform. But I think increasingly, we really want to think about how do we connect different data resources, understanding that there's going to be different tools, different places that data is coming into, and really create an interoperable setup between some of these platforms. So I'm going to shift gears a little bit. I'm going to talk a little bit about the Kids First Data Resource Center, where we use Cavatica as our primary platform integration. So Kids First is a program in the US that launched 3 or 4 years ago with the idea of generating whole genome sequencing data across structural birth defects and pediatric cancer. The idea being that there's shared developmental biology underpinning that, and really trying to understand some of the genetic etiologies of these different diseases. And it's been a very interesting project where About 2.5 years ago at CHOP, we were awarded the Kids First Data Resource Grant to take in all this data, harmonize it, and make it available to the community. So this was actually 2 years after Cavatica. So Cavatica launched in 2016, and then the Kids First Data Resource Center came along, and it seemed like a perfect opportunity to say, how can we provide this data to the pediatric community, but also have that coupled with a cloud-based workspace that people could immediately have access to the data and hopefully accelerate the research processes that they were working in. So I'm going to switch over to a little bit of a demo towards that. So this is the Kids First data portal. Anybody can go in there. You'll be asked to log in either with a Gmail, Facebook, or OrcID, but you don't have to be on a list or anything like that. And the idea of that is really to have a user workspace where you can have a dashboard, have different kinds of integrations, and have that as a jumping off point to multiple different platforms or collaborations. So once you log in, you have your dashboard. So you can see that you have the ability to save queries, have different authorization of studies, and then on the right here, you can see at the beginning of these Cavatica project integrations. So since Cavatica has a pretty robust API, the portal development team for Kids First, which is in St. Justine, was able to create these different integrations that allow us to here create projects, see other projects, and go between Kids First and Cavatica a little more seamlessly. So in the Kids First portal, for example, we have this Explore Data feature. Just clear that out. And what this allows you to do is interactively look at different data types across both Kids First, as well as some integrated data sets from NCI, the National Cancer Institute, as well as some consortium data sets. So this would allow a user to come in and say, you know, for example, maybe I'm looking for neuroblastoma data sets. I can apply there, and I can see that there's a neuroblastoma data set that was done by Kids First. There's one from Target, and there's actually a few cases in the Pediatric Brain Tumor Atlas as well. So you could filter down, for example, I think a standard thing that people want for cancer analysis is I want to find, for example, all of the tumor normal pairs that are available to do analysis on. So top of the diagnosis, I could go to biospecimens. I can go and say, I want to see all the tumor tissue. And then in this interface, you can actually duplicate the query and say, okay, instead of tumor, I want normal here. So I can see here there's 593 participants with tumor tissue, 653 of normal. And then I can combine these two queries and find out how many subjects have tumor normal data available. And you can go and further refine these different queries. So for example, if I want to do, I know I only want to look at whole genome data, I can add in whole genome as a criteria, and it's updating in real time. And I can see that when I look at whole genome, now I have 310 participants that have tumor normal data with whole genome data. And so you can navigate down through this and see, you know, different information about these. And this searches across all the Kids First data. So as I said, you know, there's like different congenital diseases. We have different heart defects, oral facial clefts, as well as Ewing sarcoma, leukemias, and a lot of other data coming down the line as a resource for looking at pediatric data. But kind of to get back to that, a lot of times, you know, in these resources, you're searching the data, that's great, and you get to this point and you say, okay, now I need a manifest to download. What we really try to think of is how can we go more seamlessly from this to a platform like Cavatica. So I can go from here, I can click on files, and then this will take me to the file repository where I can see the actual specific files that are related to that cohort that I just built. And as you can see, there's different levels of data, different levels of files, but let's just assume I was interested in looking at the actual aligned reads and doing some sort of new variant or SV or some sort of algorithm that I brought into the Cavatica platform, I could say I want to select that down to the aligned reads. I want the harmonized data, which is on the reference 38. And then I have something like 500 files, 9 terabytes in size. And in the past, when I might have to download this, move it to a different place, here we have an immediate integration with Cavatica where I could say analyze into my Cavatica project. And this is calling that Cavatica API, creating the different projects there. And for example, I could create a new one. Authorize to copy 507 files. Under the hood, this is actually doing a lot of work to authorize, check with the NIH services that indeed I have access to this, and click on copy, although really it's not copying. All the data is in the cloud in the same region as Cavatica is running. And this is really just going through and checking my access to all the files and creating pointers into the Cavatica project. Always trying to do a live demo is fun to wait and see how long that actually takes. There we go. So not too bad for about 10 terabytes of data. And then that gives me a link that will take me over to the Cavatica project. And hopefully if this all worked, you'll see that I have all my files here in the Cavatica project ready for me to do all those different features, workflows, interactive analysis that I showed before in the presentation. So while I'm here, I can show you kind of more live time, some of the things that are showing in the slides. So for example, we have the different public apps. And you can see that there's at the top kind of multiple feature apps. So if you're interested in, what's available in terms of fusions. You can see that. You can also search. We already have kind of high-level categories of different tools that might be of interest, kind of different toolkits that you might want to bring in. And similarly, as I was saying, there's both public apps that are maintained on the platform, as well as, for example, for Kids First. We've been publishing our different applications here as well. And so what this allows you to do is say, again, if I brought that data, imagine it didn't come from Kids First, I wanted to bring one of the workflows to it. For example, I wanted to realign it. I can select a project, go to my webinar demo, and then immediately bring in that application into that project that I just created with my new data set. And one of the nice things is that when you define and publish your workflows on Cavatica, you can say all the references that you'd recommend. So instead of going and having to dig through them, you could say, yes, I'd like to copy all those references to here. It will automatically populate that information. And then really what you need to do is then just name your different outputs and inputs for the files that you're creating. So you select your input file, BAM. So we can select one here. And then you can name and then as a workflow developer, you can have this kind of auto-populate all the different ones. And then you can actually run the task. So it will queue it, and then you'll get notifications as the task gets started and is awaiting to actually get run. Again, there's nothing going to be here right now, but all the different stats and tasks will show up in the dashboard as it gets started running here. And then similarly, so now in my webinar demo project, I have that workflow, and you can see I could edit it, copy it, and create new versions of it. So if I wanted to modify it, bring a different tool up to date, change different parameters, that can be all done, and that's tracked on the platform. So here's. And then again, similarly, you know, one of the real ideas of here is having collaborative projects, so you can invite new members. So I can find Young Kuhn here. I could add him to the project. And then there's different levels of permission. So if I wanted to add someone just to be able to view and look at the files, I could do that. Being able to execute, run tasks, or actually being able to write, so add, modify, through the different files and applications. So I think that's the main functionality I wanted to show. There's quite a lot here. I think I will. I was going to show that docs.cavatica.org. So everything that I was just talking about is documented. There's a lot of quick start API, different developer resources as well. So this is a good place that if you want to go and get deeper information, you can go here. Then I will go back to my slides. And so, right, so over the last couple of years, we've developed a lot of these integrations, continue to expand the Cavatica platform. And part of why I'm here today giving this webinar is that we are in the beginning phases of launching a pilot for Cavatica Australia. So over the last couple of weeks, we have been standing up an instance of Cavatica in AWS Sydney and starting to work and try to understand what the different workflows look like across different regions of AWS. So this is a brand new, but I think, you know, over the next couple of months, this will be evolving, and, you know, interested that if there are folks out there interested in this project, you can reach out to us or the BioCommons folks, and really starting to think about, you know, how do we do collaboration, you know, not just within the US where Cavatica has been before, but globally, especially I think with the different pediatric diseases having, you know, being fairly rare. How do we kind of combine our powers? How do we think about how we can do research in new and innovative ways collaboratively? And there's a lot of interesting things kind of under the hood technically of, you know, for example, reference files as a quick example. You know, if we need to copy them all over, you know, we don't want to do that all the time when we scale this. What needs to be copied over, what doesn't? How do we have large scale data resources that are across the globe and bring the different compute workflows to there? At what level do we have high level data that we can aggregate and analyze together? So I showed you some of the documentation. And I said in the bottom right there, there's always a general help that can go to a general support queue, as well as quite a bit of documentation out there. Always looking for feedback, ways that we can make the documentation better. And then also something I didn't show is that specifically on the tasks, you can also get support, and that will provide all the technical teams all the detailed information. So if a workflow fails, other aspects of there, you can do that. So that's really what I had. I think running through the slides, and since I have a little bit of extra time, I just want to mention two other kind of features of Cavatica. One is that the workflows can leverage spot instances on AWS. So this is the ability for the kind of market on AWS. You can have a spot instance where it can spin up, be much lower cost, at the idea of it might be taken away before you're done with it. In general, we don't see too much of that happening, so it's a great way to have lower cost on the cloud, as well as a new beta memoization feature, which as the workflow is running, if it crashes, it keeps the temporary files of the last known successfully completed step and can resume and continue the workflow along the way. So those were two other things that I had meant to mention about the platform. But other than that, hopefully that was a good introductory tour. Showed a little bit about how the Kids First Data Resource Center has been leveraging Cavatica to integrate with it, and happy to take any questions that might be out there. Thank you.
Thanks very much, Allison, for the overview of the Cavatica platform. And so now everyone in the audience, it's your chance to write a question into the box on your dashboard if you'd like Allison to address any particular topic. Just while we're waiting for questions to come through, Allison, I wonder if you can tell us a bit more about the activities that have brought you to Australia. You're currently here at the Children's Cancer Institute in Sydney with other members of your team and a group made up of Zero Childhood Cancer and 7 Bridges researchers and ARDC and Australian BioCommons staff. Can you talk a little bit about what you're up to?
Yeah, I think it's been a really great partnership. This actually stems from a visit about a year ago when myself and Adam Resnick, who's the director of the D3B Center at CHOP, came and visited as part of multiple events, but including the Lauren Cancer Conference down there, and met up with Zero Childhood Cancer and realized that we were doing very similar workflows. So at CHOP with CVTDC, we have a large research endeavor for brain tumors, as well as a partnership with the Pediatric Neurology Consortium, which is running precision medicine clinical trials for brain tumors. And so intersecting that with what Zero has been doing here in the precision medicine, I think there seem to be a lot of different synergies, different workflows. And again, you know, pediatric cancer is often rare, and we don't get as much power as adult cancers do. And so by combining forces, we really expect that we can improve some of the outcomes. And then along the way, meeting with the ARDC folks and the Australia BioCommons that are really, I think, powering the infrastructure that makes this happen, right? The science and the precision medicine, you know, at the scale of using genomic data really needs solid kind of technical infrastructure. And I think really appreciating all the work that's been done in Australia. I used to do a lot of work in cloud computing and really seeing some of the Nectar systems and other things that have been done here have always seemed like it'd be a great opportunity for collaboration. And so it's been really interesting, and I think it's a new world where we're trying to understand what do we do on commercial cloud providers, what do we do with our national resources, how do we make most efficient use of the different cyber infrastructure that's been set up, while also making sure that the different both research and clinical workflows can happen. So yeah, down here we brought some of our bioinformatics team and to do a little bit of a workshop kickoff of some of the new features in Cavatica Australia. And so it's been really great. Always love coming down to Australia.
It's great to hear. So I'll ask, there's a couple of questions come in. First of all, there's a thanks for a great presentation. And the question is, I'm curious how Cavatica is licensed. Is the code up on GitHub or a similar platform?
So Cavatica itself is a 7 Bridges product. So the workflow engine and the UI and the things you're seeing are a proprietary software product. However, all the Docker, CWL, and the workflows themselves are all open source. So for Kids First, we actually have a pretty robust GitHub, and all that CWL, the apps that you saw published are actually, the actual CWL is on GitHub. And we are always open for issues or problems that you see. We're pretty active and very big advocates of the open source community in terms of the pipeline development.
There's another question here. Is this suitable for only cancer data or equally okay for germline rare disease?
I'd say it's equally. I'd say it started, the data that we brought to the platform really started in the cancer space. But as you saw, the workflows are CWL and Docker, so they can be anyone that you want. And for Kids First especially, we are doing a lot more germline data these days. So we have a lot of trio studies. We're doing joint genotyping, and then we've also been working with 7Bridges on some new graph genome algorithms as well. So the platform is kind of, at the end of the day, agnostic to what kind of workflows or tools you want to build. We've actually been talking a lot about imaging data more recently. So it's not just genomics, even like would you bring different kind of MRI or pathology images and have the tools that would do feature extraction or machine learning on top of that. So it's not just for genomics, but I will say that a lot of the features have been geared towards these larger genomics workflows, but that can be leveraged in other data types as well.
Okay, that's great. Well, thank you very much for that. I'll once again express our appreciation to you, Allison, for sharing your work with us today. And I think we'll bring the Cavatica part of the webinar to a close. So thanks again.
All right, thank you.
And to wrap up, I'd like to give thanks to the collaborators on this project that have brought our wonderful speaker here today. The Children's Cancer Institute Australia and the ARDC. Now, the ARDC and Australian BioCommons are both enabled by NCRIS funding, and in the case of the Australian BioCommons, that happens via BioPlatforms Australia. So thanks so much for watching, and we hope you'll join us next time. Goodbye.